All right. So I'm Kyle, AA0Z. I'm sure that probably everyone has probably seen me around. We do classes, we do Elmering sessions. Pretty active in the club. A little background, I got my license in '95 up in Kirksville. Was KB0 RPM, did a bunch of stuff with, well, the reason why we got our license was I was on the Mizzou solar car team, and we used ham radio to communicate back to the chase vehicle. Our radios that we had just didn't cut it. We didn't have enough money to buy like a frequency. So we used ham radio to communicate back to the chase car. And we all went up to Kirksville, got our license, ran solar car stuff that next summer. It's called Sun Race? No, Race? Yeah, Sun Race. And I put the hobby down for 10 plus years and then got back into it 15 years ago. So it's about me. We will go into the presentation. All right, pop quiz. So you don't have to yell these out. These are going to be answered at the end of the presentation. But how many repeaters does SLSRC maintain? How many repeater sites does SLSRC maintain? So now, what?
Is there an echo in here?
No. Well, how many repeaters? How many repeater sites? So they're different. Okay. How many SLSRC owned repeaters operate in the 2-meter band? How many operate in the 70-centimeter band? You guys thinking on these? Who manufactures System Fusion? How many SLSRC own System Fusion repeaters are on the air that we own? That might be a hard one. And then, all you old fogies over here, who owned the building?
The blue chip of the savings business.
Yep. Owns the building that the 146.91 repeater is currently located on. Right now, it's owned by Edward Jones. But who owned that building? So we'll see the answers at the end of the presentation. So word to caution to you, I got a ton of slides. We're going to blow through these quite quickly. So if you have a question, stop me. We're going to try and get through it, but I've got a ton of slides here. So hopefully we'll be out of here by 9 o'clock. All right, show of hands. How many use the repeater system that we own? Oh, good. How many have a System Fusion radio? Oh, more than I thought. Okay. How many of you know where to go find info on the repeaters? Oh, okay. Good deal. All right. Who uses digital voice on 2 meters? Okay. How many of you would use System Fusion if there was more activity in the St. Louis area? About the same. Well, a little bit more. Okay. How many of you have a DMR radio? All right. Interesting. Okay. All right. We announced this about a week ago, the 146.85 repeater. Now it's got an output tone, a CTCSS output tone. So if you know how to program your radio, go ahead and program it if you're hearing the repeater in Southern Illinois. Okay? I live in South City. I hear those guys every single day. Right? Some of you live in North County, St. Charles. You probably don't hear it. Probably don't need to program it, but it's on. Joe did all the work. Thank you, Joe, for all the work that you did on that. It took us a while because we had some fusion issues. We had to send some fusions back. We'll get into that later. We did a lot of testing. We put it in. One of the things that I was talking about is our not so successful efforts, and we put the repeater in, had some audio issues. We brought it back. We did some testing, got it up and running. So thank you, Joe, for doing all that testing and getting it up on the air. Appreciate it. And then also, the 224.520 repeaters on the air. Again, Joe fixed it. I'm not really sure what was wrong with it. They had an output problem, right?
No, it just had an open capacitor in the audio circuit. So basically got audio in, the receiver sounded fine, the transmitter sounded good, but the two couldn't talk to one another.
Gotcha. So it's back on the air. It is at the 8.5 site, so 9666 Olive is on the, it's on that site.
I would be curious, by the way, what anybody has any feel for what kind of coverage that thing gives, because the other thing that was put up, what, a year and a half ago?
Yep.
They actually put a real 220 antenna up instead of that mobile whip that they were using in the past.
Yep.
I'll try it tonight.
We're one of the far ones, so we'll give it a shot.
Yeah. Cliff is, I think Cliff is on 220. Don't you have 220? Yeah, and Max has got 220.
It's not as strong as the one that Roger had, but that's on a higher tower, I believe, a little bit closer.
So Doug, if you,
That's on a J-pole in my basement, so it's got some pretty good coverage.
so if you get home, give a call out tonight and see if you can raise anybody. Okay.
Do we have a 6-meter repeater? No.
We do not have a 6-meter repeater. We used to a long time ago, but I don't know when they removed that.
I don't think the club had a 1.2. There was a 1.2 in St. Louis at one time, very early 2000s,
Okay.
but it was very
Mike
limited use.
Music had the 1.2, but it got hit by lightning and we never did. He never put it back up.
Okay. All right, so some things about the engineering committee. So I took over the engineering committee probably November of last year. So we've got a team of 17, 19 on the mailing list. So we got 10 new members in the last 6 months, which is great. The membership was about 7, so we're up to 17. We design, install, support all the SLSRC repeater systems and the 5 gigahertz point-to-point network. We'll get more into that later. Hold online Google Hangouts every 2 weeks on Sundays and Thursdays. Second Saturday of each month is repeater workday. So we go to a repeater site and work on it. Everything from labeling stuff, testing radios, testing coax, putting up new antennas, whatever the repeater needs, we make a laundry list and we get stuff done. We also support the equipment for local public service events, so that actually the cross-band repeater for Bike MS, if the original one poops out, we've got a backup. So Joe built that one. Joe's a jack of all trades today. We maintain a state of backup equipment for emergencies. So we've got a generator. We've got repeaters that we can put up in a moment's notice. We've got a tower. We've got coax. We are fully capable. If the New England earthquake hits tomorrow and we need to put people on the air, we can do it.
Well, look what we did at Field Day.
Yeah, yep. That was a good example of what we're capable of if there's an actual disaster. We got an operating budget about $3,000, and we try and communicate with the community, upgrade the status of the SLSRC repeater system on a regular basis. So Facebook, email, website. So we don't do anything in the dark. We try and communicate all of our changes and things that we're doing. Okay. Introduction. So here's the engineering committee. So give a wave so everyone knows who you are. So Dan, Eric, Tony's in the corner, Phil, Sterling's not here, Alexandria, Mark is over there, Rebecca is working, Bill, Phil is not here, Max, AJ's not here, Art, hey, Art. And then I want to recognize the 3 guys that are our control ops. They do a lot of work. They are the people that are maintaining the repeaters on a day-to-day basis. So Charlie, he maintains the 9.7. Steve, where's Steve? Steve is the 9.4 and 443-100, and then 442-100. Sorry, and Joe is the 146.91. So thank you guys for maintaining the repeaters. Appreciate it. They do a lot of work. This maintaining the repeaters and doing the engineering committee, it's a lot of work. But we've got a great team. So All right, how to get involved. So we need you to help get involved. We need more volunteers. We're always looking for more volunteers, right? So you don't need to be technical. You don't even know, electronics. Sometimes we just need hired hands to go out and do stuff. I'm one of those hired hands. I don't know a lot, but I go out and I label coax and network cables. So I leave the technical stuff to the technical people. And that's what they're good at. Looking for all skill levels, and then if you want to get involved, let me know. Okay? So the control ops, again, I help with the, so we've got 4 repeaters, or we've got actually 5 repeater sites, but 4 that actually have repeaters at them. So 9666 Olive, myself and Joe, 1255 Manchester Road is Joe, 200 South Brentwood is Steve, 665 Skinker is Charlie. Here's our home page. So if you come over here to the quick links, we're the second one down. And then also, we'll go over the notes, but I write a blog post every month on all the things that we're doing. Sometimes I forget, and it's a little bit late, but usually it's the first week in the month. So I try and do a verbal vomit of everything that we did in the past month. And here's the blog. So if you go up to committee notes, and you come down here to engineering, it's kind of blurry, but that's where you can find it. And then here's our repeaters and nets page. So all the information about the repeaters are on this page. Even some stuff about digital fusion and how to set your radio up. Because if you have an analog radio and you tune to a digital signal, you're going to hear digital hash. You don't want to hear that. So if you scroll down to the bottom of this page, we've got a little blurb on how to set your radio up. Man, that looks all washed out, doesn't it? So here's the sites. So to orient yourself, here's Forest Park. Here we are. 270 runs up and down. So there is 9666 Olive. Here's Brentwood. Here's Skinker. And then Manchester's down here in the corner. And those are the current repeaters that we've got on the air. All right, so what is a repeater? So going back to basics here, so you've got a handheld. He is listening on 8.5. He is transmitting on 2.5. 600 kilohertz offset comes up, hits a repeater, gets amplified, and then Jane down here can hear it on the other side, right? So that's basically what a repeater does. Nothing fancy, just magnifies signal, pipes it out the other end. So why do we need repeaters? So extend the coverage, common place to hang out, right? It's like ham radio, chat room. Provide emergency communications. Provide community service, so bike events, marathons, different things, and then also our net. All right, repeater coverage. I have a Baofeng HT. Why can't I hit the repeater? Well, it depends. I have an 8-gain antenna running 50 watts. Why can't I hit the repeater? Well, it depends. I got a J-pole connected to my HT. Why can't it? Well, it depends also. Everything depends. All the conversations start with it depends, right? Propagation could be horrible. You could have a building in the way. Your HT could be malfunctioning. Your SWR could be off. Who knows? But that's the most common question is, the repeater sounded horrible tonight. Or, I can't hit the repeater whenever I'm south of the hill. Well, guess what? I can't either. So it all depends. I think the most common is, the repeater sounds like crap. What's going on? I don't know. I don't know.
Let me
And-
get this right. You're not the technical guy?
I know. I'm gonna keep telling you, I don't know. But when I keyed it up 5 minutes ago, it sounds great. So I don't know what happened at 7:30 on Tuesday and you couldn't hit the repeater. Have no idea. But everyone else could get into it. So again, it depends, right? So this is just we've got, Max did a bunch of great coverage maps, and we'll show you those. But here's kind of just a general thing that I threw together, and people are going to have their own opinions, right? So you got a 5-mile radius, probably hit that with an HT. 20-mile radius, probably need 10 to 25 watts, and probably a decent antenna to get into the repeater. I know because I go down to Belleville, and I cannot hit the 8.5 repeater in Belleville, Illinois, with my quarter-wave antenna on my car. And I'm running 50 watts. 30 miles out, 10 to 50 watts with good outdoor antenna. How many miles away are you guys? You guys are up here, right?
Yeah, we're outside here. I think it's like 52 miles.
And do you guys have a Yagi pointing to the, or do you have Omni? And how many watts do you use?
25 most of the time, 50 sometimes, but we hit you with 25. I've hit that repeater with 5 watts.
Yeah, it all depends, right? It all depends.
Bill, Pam, and Bob.
Pam, yeah, you guys live in High Ridge, right?
Yeah.
Villa Ridge.
Is that right?
Yeah, so we're a little bit outside that
Here?
circle there, just by a couple miles. I think we're about 32 miles from the repeater, but we can hit just about any repeater in town.
And what do you guys use?
We've got a 10-element diamond up-beam.
Yeah, you're gonna blow all the doors off of it with a beam.
Well, I'm sitting in Imperial with my J-pole at 50 watts.
So here's a good example. Al has checked into the net. I've heard probably 3 or 4 times. He's probably checked in 1,000 times, right? 2 weeks ago, you were barely readable, right? You were very weak. The week before, you were strong. It depends. It depends.
I'm about a mile south of Highway 21 in Elm. Basically an auto. And I'm talking on a Belfane handheld,
Yeah.
and with the J-pole that lift that build on.
How high?
I'm on a pretty good sized hill. But I've been hitting it since then with that handheld in a bedroom.
Perfect. Depends.
The hill.
Yeah, the hill helps you.
I found one more. Tina had for 3 years a J-pole out in O'Fallon, maybe 30 miles from the 8.5 repeater, and went to a 4-element beam in an attic, not on a rotor, but pointed at the 8.5. And when she checks in, it sounds like she's next door.
Yep. So I live here, and I had just a J-pole on the other side of my roof. Couldn't hit with 5 watts, couldn't hit it with 10 watts, had to bump it to 25 watts. So I live here, and I couldn't hit it with 25, or with...
How high?
Well, the problem is I have a big oak tree, and I have my roof to go through. I've got a 12-1 pitch roof, and the antenna was here, and the repeater's over there. So, yeah, I was in the shadow. Yep.
Kyle, one more example. The 9.4 repeater used to be on the tallest building in Clayton, or one of the tallest, and had great coverage. This is 10, 12 years ago, until it was on I think it's 23 stories, right above Shaw Park, until a 25-story building came across the street.
Well, we'll get into that. Yeah, we'll get into that. It's not very tall anymore. It's shrunk. It's shrunk. So it depends, right? It depends. All right. Here is a couple great tools that you can use to figure out it depends. Okay? Google Earth. It has got, if you open Google Earth and you go up, you can't really see it. There's Yeah, it's a ruler, and you go to draw a line. I think it's draw a line.
Or measure.
No, it's not measure. Path. Path, right? So you can barely see it. You see that line that I drew? So there's the 8.5 repeater. Here's where I live. So I live here. Here's the 8.5 repeater, right? So you come down and you can see the elevation. Obviously, I am way lower than what the repeater is, and this is ground level.
You can add it in the altitude.
You can, but that gets crazy, right? So let's make it simple. So you can come here and add, or I'm sorry, you can add. Now you got me all confused. You can come in here and take a look at the elevation path on where you are related to that repeater. Okay. So if you've got a bunch of nooks and crannies and you're down here, well, you're going to have to get more power to get up over those ridge, right? And then Sterling made a great video. There's the YouTube, and we'll put this up on the website, how to draw a line between buildings in Google Earth. That will actually show you if there's trees or buildings in the way of your signal. And I'll show you an example of it because we used it to figure out our 5 gigahertz point-to-point links.
And I forgot what button I hit, but it takes you on a joyride down the path.
Yeah, you can fly through it, yeah.
You can see where your path dives underground.
Yeah. Yeah. All right, so let's talk about typical hardware in a repeater. So you've got an antenna. So this is like a 2-meter antenna. This is 70 centimeter. You've got a pair of duplexers. Basically, duplexers allow you to transmit and receive on the same antenna, right? It rejects and allows signals on the same antenna. RX and TX radios. So those are ICOMs, a controller, which is the brains, hardline, so this is not regular coax. Some of our repeaters use regular coax, but a lot of them use hardline. You can tell by there's copper cladding around there, and there's like probably a non-dielectric foam or something. And then here's your interconductor. And then lightning arresters with a good grounding system.
How effective are lightning arresters?
Oh.
If they are properly grounded, they will save your radios.
Yes.
But everything has to be properly grounded. So, for example, Ward did a talk last summer that's out on our website. If you want a good class in grounding, basically, let's say you've got a tower, right? So each leg of the tower is grounded. There's a ring around the tower that has 3 or 4 8-foot grounding rods driven into the ground. All of those are bonded together. You bring it into your shack. Your radios are bonded to a rack rail, a grounded rack rail. The goal is to ground everything together, right? So whenever lightning hits, the potential comes up together and it goes down together. That will save your radios. This will probably pop and dissipate a lot of that energy, but it'll save your radios. Now, I'm saying it'll save your radios. Well, I grounded everything, and yeah, it depends. It depends.
You get a direct hit.
Yeah, if you get a direct hit, you're toast.
Does the arresters all have one size?
No. Well, you mean for like lightning?
Or like,
Well, they're made for frequency.
There's a little gas tube in those things that typically are rated for like 20,000 amperes peak, which some lightning bolts can be more than that, but that's what's in there.
Yeah.
When you get the high voltage from a lightning bolt,
They
it breaks
cut-
down the gas and hopefully shuts it off the ground.
Usually you can get them in either SO or N connectors.
Yeah, so you get them in the connector you want, and then sometimes you get them in the frequency range. Some of them are just HF, some of them go up to 900 megahertz. It all depends. Depends. But the key to your question is you have to ground everything together. Everything. Radios, antennas, your tower, everything else. Everything in your computer, everything in your system has to be grounded and bonded together. And mechanical, if you want to get Ward's book, he's got these things, they're called Coldshots, and you put the grounding rod in, and you put your 2-aught or your 4-aught wire, and you put them on each side, and it's a chemical weld, and it welds all your grounding rods and your cable together, or your ground system together. I've seen my friend got hit with lightning in Louisiana and lost everything, and he had everything grounded, but he had just crimp on the outside, and that's what it blew that apart and came in that way. So
if you just watch Ward's video, that'll get you.
Yeah, Ward's got a video out on our website. Just watch it. You'll learn everything about grounding that you want.
What is bonding?
Bonding is just the process of connecting your ground wires to whatever you're grounding to. So bonding and grounding, it's just the matter of, it's the verb. You're bonding something together.
But caution, when you're dealing with power coming into the house, bonding is a different subject.
Yeah, RF bonding and RF and high voltage bonding are totally different. Watch the video.
Cal, grounding and bonding for the radio amateur ARRL Ward Silver Amazon.
$23.
I don't have a price on it. I
Yeah.
haven't looked at it, but it's March 2017.
I think there's a Kindle version too.
You can also get it on Kindle if you want to.
Yeah. Yeah, if you're going to put a shack together, get that book. You won't regret it. All right. So same things. Here's the order that the order that they're connected in. So the controller here has got ports on the back of it. It connects into the back of the radios. The radios connect into the duplexers. Connects in the lightning arresting system. Connects into the coax. Then it goes to the repeaters. So that's basically it. All right, a little bit of the hardware that we use. So we've got 2 of these systems in play today. They're Vertex 5000s. We've got one that is a 2-meter, that's the 9.7. And then we've got a C series, which is 70 centimeter, that's at Steve's location, 442-100. 25 continuous watts of duty. They're external or internal controller. So we pulled one out of 9.1 that had a external controller, but the one at the 9.7 has got an internal controller. So you can get them in both versions, and they're AC and DC powered. So these are Yaesu repeaters, right? They're Yaesu, right? Yeah. Okay. So the club in 2015 bought a bunch of System Fusion repeaters. Yaesu was doing a promotion, and you could buy, I think it was up to 5, maybe 7, I'm not really sure, for $500, a repeater system for $500. So they wanted to flood the market. So we bought 5 of them. The club did. We still have some outstanding, but we're getting them in. So basically, we've got 4 of these DR1Xs. Here's the front panel. Here's the back panel. It's got a TX and an RX power. It does accept AC power, so it's got a power supply in it. So these are the first gen $500 club deal. They do System Fusion, FM, and AMS mode, automatic select mode. We'll get into that later. Basically, it automatically figures out if you're digital or if you're analog, and if you're on a Yaesu radio, it automatically switches. They're 5, 25, and 50 watt outputs, but they use an FT1000. If you know what an FT, it's an FTM. I think it's an FTM 1000. They're consumer mobile radios inside, and we'll get to a picture of them. They recommend these first gens to be run at 25 watts.
It's actually 20.
Is it 20?
Yeah, it's only 20.
Okay.
And if you run them at 50,
They blow up.
they'll probably burn them up.
Yep.
Actually.
But they learn from their mistakes. So we've got 4 of these. They've got an onboard repeater controller, so you don't need that external box. They got that front panel display, which is a touchscreen. So to program these takes 4 or 5 minutes. That's all it takes.
Well, I make one point about the controller. Controller in these is pretty basic. I mean, it does the absolute minimum you need for FCC, which is ID and timeout. You can't do stuff like play Newsline through it.
Yep, we're going to get into that.
Things like that.
Yep. So about 2 months ago, I put together a proposal, and we got one of the new versions, the DR2X. We traded in our 5th DR1X, paid Yaesu $500, and we got the new version. So what does the new version get us? Well, it gets us C4FM, AMS, and FM modes. It's got auto back down, so they recommend you run it at 50 watts. And if it gets too hot, it will back it down to 20 or 25. And then if it gets way too hot, it'll back it down to 5 watts. It's got dual receive and single transmit. So look at it's got 2 transmit and 2 receive. But you can't transmit 2 signals at once. So it's really only single transmit, dual receive. That dual receive is a back door to control it. So it listens on 2 frequencies. So let's say the transmitter's locked up and you can't get into it. Well, you get on the second transmitter. I'm sorry, you get on the second receiver, and you're able to control it through DTMF codes that way. It's got more controller features through DTMF. So the first gens, it's really a dumb controller. It does not do a lot of stuff. The new version does a lot more stuff. You can put it in FM mode, you can put it in AMS mode, you can turn it on, you can turn it off, you can change the power setting, all through DTMF. It's got this IRMS linking, so basically it's just IP to IP. So they put an Ethernet jack on the back of it, and now you're able to link them through the internet to other DR2Xs. And then also it's got a direct Wires X connection. So Wires X is the DMR of System Fusion. It's like Echolink, right? It's like IRLP on steroids. So what you can do is you can connect that Wires X to the back of this repeater and get directly into the Wires X network.
Kyle, let me kick in one more comment about the DR1X as well. Controller that does not provide a courtesy beep either. And that is one difference in the way our repeaters operate. If you do not hear a courtesy beep, the 3-minute timer does not reset until the transmitter drops out. If, as on the 85 machine where there's an external controller and you do hear the courtesy beep, that's when the timer resets.
Yep.
So if you, like for example on 9.1, if you pick it up too quickly after somebody turns it over, before the transmitter's had a chance to drop out, the timer hasn't had a chance to reset. They're liable to time it out if you get really windy and talk a long time. So that's one difference in the way the machines work, the newer machines work.
Yep.
So 9.1 has the delay time set to ½ a second. So once the receiver drops out, the transmitter only stays on the air for another ½ a second before it shuts off. That's one of the reasons that time period is fairly short. It's so that the transmitter will drop before somebody else picks it up.
So that's what the insides of the DR1Xs and 2Xs look like. So they're literally mobile radios. That's it. And then you've got, I think this is the controller. You've got the wiring for the display. You've got a speaker, a fan, a speaker, and another fan, and that's it. That's what it's the internals on them. All right. So to get into the Fusion controller versus the CAT controller, so Joe had a bunch of good thoughts there. So the internal controller in the DR1Xs, it's got limited control, no control of the timeout, so it's set to like 3 minutes. I think you can do 1 or 2 or 3 minutes, and that's it. There's no, oh, we're going to put it in net mode and going to, I hear that, and all I think is R2-D2.
It's Star Trek.
I'm not a Trekkie. I'm a Star Wars guy. Sorry. I have yet to see one Star Trek movie. Haven't seen any of them. So.
That was your 1 hour warning.
Well, we're blowing through this, man. We're good. We're good. So, no control of the timeout timer. It's easy to configure. Provides native AMS mode, so automatic select mode, and no Aries paging tones. Right? So it's very limited on what it'll do. What you can do is you can get an external controller. You can hook it up to, there's a 15-pin on the back of it, the Fusion repeaters, and you can use your old controller. The problem is you have to put it in FM mode only. So you don't get the capability of digital by using an external controller. This is how we are running the 8.5 today. The 8.5 does not have digital capabilities on it. We made a decision as a committee to put that guy in FM mode only. So it's got DTMF control. It's got many features. We can control the timeout. It can be difficult to configure without software, right, Joe? It's a pain in the butt. The manual for this guy is not written very intuitively, and it will put you to sleep and it'll tear your hair out. And we worked on getting the 8.5 controller software just to talk to it. We worked for a month because we had to bring it back to Joe's house. We had to reset the password on it. We didn't know the password. It's a pain in the butt. But we are in a better place now because of it, and we've learned quite a bit on how these things are programmed. If one fails, we've got a backup. We can put one in instantly. We learned a ton the last 3 months on this. Again, does not interface with digital repeater without a special board. We'll get into that later. Only uses FM, and this is how we produce our paging tones for Aries. So if you listen to the Aries net, those tones that go off on the people that are in Aries, your boxes, it's produced through the controller.
But also as a voice synthesizer, that's how you get the voice ID. The DR1X is nothing but CW ID is all they can do.
All right. Next, our budget runs from October to October, right? Is that right?
I believe that.
Yeah. Okay. Yep. Got the thumbs up from Vern over there. So we're probably going to buy 2 CAT 800s. That is the next generation in controllers. And this is the board. And it's actually got an Ethernet jack on the back of it, which is amazing. But this is the website or the web browser that it has in it. It's pretty janky. But this, what? How much are they? $400. But if you buy the rack mount and you buy the faceplate for it, and there's something else you have to buy, it's like $575. But this is the latest and greatest, if you can believe it. Like I said, there's a company called Arcom, and they produce repeater controllers also. They make a board. Whenever Yaesu released all these repeaters, they make a board that you can literally snip some wires, go in there and solder this board into the Fusion, and it allows the fusion to do digital and be controlled externally FM with a controller. So we're going to experiment with that in the fall and see where that gets us. It's $165 with the CTCSS controller. So the internal controller does digital, the external controller does FM. All right. Well, whenever we were going through this process, we met with George, who's going to do a presentation on digital, and he said, oh, well, you can't control a fusion with an external controller if you've got anything less than 1.1 firmware. And we're like, you got to be kidding me. Nope, you got to upgrade all your repeaters that you want to put on a controller, you got to upgrade. So we went through the process of upgrading our controllers, and you have to send them back to Yaesu in California to do this. Every time we sent one back, it was $75 with shipping and insurance. So we did the repeater shuffle here. We had an 8.5 at a fusion at the 8.5. We upgraded that guy. He went to the 9.1. We upgraded that guy. He came back and became the 8.5 Fusion. We had a spare one in my basement. We upgraded that one for the 9.4. We traded that one in. That one became the 9.4. We're going to upgrade that guy. It's going to become the 9.7. Find the upgraded DR1X. It has been a pain in the butt upgrading these things and keeping track of them. So a little bit about AMS mode. So basically, it allows digital and fusion, or digital and FM, to reside on the same repeater. Basically what it means is if two people are talking digital and you want to key in on the conversation, there's some jankiness that goes on there. But whenever you key into the repeater and give your call sign, it recognizes that you're coming in through FM, then it switches everyone that's talking on a Yaesu radio, it switches them to FM automatically. So that's basically what it does. Unlike DMR, you're 100% digital, right? System fusion, you can live in the analog world and the digital world at the same time. Now,
does it matter if you're using a different brand?
No, because my Kenwood, if I key up on, if this guy's in digital mode, and I key up on my FM signal, it's going to send the FM side of the repeater is going to recognize that, and then it's going to send a signal out, an FM signal out, and switch it internally, and all the radios that we're listening on digital, the Yaesu radios that we're talking on digital, it's automatically going to switch them to FM. That's the janky part of it. So, yep. So on all of our digital system fusion radio, our repeaters, we have CTCSS on the output turned on, right? So you're going to see it busy, right? It's going to be 5.9 plus, right? Okay. The issue that I've got with system fusion is, all right, whenever I see that drop, all right, I'm going to throw out my call because I want to get into the conversation. They could be talking about something I don't care about, right? Now I've thrown out my call, right? Now I've switched everybody to FM, and now everyone's pissed off at me because I've switched them off to FM and they want to have a digital conversation, right? It's not the best. Right? If you could chunk it, it's going to switch everybody to FM. So,
how does it go back?
The conversation has to drop, and then someone has to put the radio in full digital, not digital/analog, AMS mode on their side. They have to put it in full digital and kerchunk the repeater. Right. So You solve this by not doing this. You put them in all digital mode, and you say, screw it. That's what you do.
If you want FM, use the other point.
Right, right. We've got 7 repeaters. We put 2 in digital and 5 in FM. Everyone lives together, right? Okay. So real quick, here's some system fusion radios, right? So you got the enterprise class here. You've got the HF. If you want to get into it and get cheap stuff, there are budget radios, right? So I just wanted to put that out there, that there are cheap radios. Everyone thinks, oh, no, I can't buy a Yaesu radio. They're too expensive. They're cheap. They're cheap. Okay. Wires X, real quick. Basically, it's the Echolink IRLP. So you've got radios here. You're connected to the internet. In DMR, they're called talk groups. In System Fusion or Wires X, they're called rooms. There's a STL Metro room that we own. There is an Aries, a Missouri Aries. There's thousands of rooms. You get the software, you download it, put it on your computer. It populates all the rooms. You can see all the rooms. You got to have a Windows computer, though, if you want to do it locally. Well, I say that. You don't have to, but we'll get into that. How do you access Wires X? So you could do a home server mode where, and this is where it's janky again. This is where I don't like it. You've got a Windows computer. It runs software, the Wires X software. It talks to another box that you have to buy, an HRI 200, which is $120. You hook that up to a radio, and then they allow you to get on your HT and talk to your radio. Then that talks to the HRI 200, which talks to the Windows box that goes out to the internet. Why they did that, I don't know. It's a pain in the butt, right? But there's more updates coming that would allow you to connect this guy or this guy directly to your Windows box through a USB cable. You're connected USB, and you can talk on a Wires X room without the HRI 200.
But you know, Cal, since you
Hey.
oh, sorry.
So, I gotta tell you, I log on to calls repeater all the time in St. Peter's,
Yeah?
and we don't do any of that. We log on, we push the Wires X button, it takes us directly to the internet or to the room selection, and we pick, okay, you get there. All right.
I'm getting there.
Okay.
Yeah, you're getting ahead of me, but yeah, I'm getting there. So there's another way you can do it. There's 2 more ways you can do it. You can get a hotspot, right? And it talks to the internet. You program that for the room that you want. That thing runs on a Pi. You get into the web page. You want it to get into America's room or CQ Worldwide or whatever the room is. You program that guy. You talk to on the HT. There you go. Another way is you talk to the HT and you got a repeater that's connected to Wires X. You hit your Wires X button, all the rooms pop up, you connect that way. Okay? IMRS linking, so that was the linking over the internet. Basically, you can link, and there's a thing called DGID. DGID, all of the repeaters get an individual DGID. Whenever you key up the radio, you say, oh, I want to talk on these 3 repeaters. You figure out through documentation, all right, that's DGID 24. You program your radio for 24. You're talking on these 3 repeaters. Let's say you only want to talk on these 2 repeaters. So if that's a configuration, you dial up DGID 22, and you're talking on those 2 repeaters. So that's their linking ability. More to come on that. We're trying to get that going in St. Louis. I don't know if it's going to take off, but we'll see. All right. One thing that I'm working on with other groups, Missouri Digital Group, St. Charles Group has got a DMR station. I heard Bears maybe has got a station, a DMR station now. We're going to try and put one large digital presence in St. Louis. So it doesn't matter if you're DMR or you're System Fusion. There's a bunch of guys on the internet that are providing boards. This dvswitch.groups.io. Basically, You can go in System Fusion, hit a hotspot, go in through the internet, it gets converted, and it comes out DMR, or it comes out System Fusion. So there's just, hopefully, in the future, this is what we're working on. I don't know if it's going to come to fruition, but it's just going to be one big digital network in St. Louis. Doesn't matter if it's System Fusion or DMR. Doesn't matter. Hardware agnostic. So people ask me, what should I get, a DMR or System Fusion? It depends.
And it may not matter.
Yeah, it may not matter. That's what we're trying to get to. Right? That's the goal. But some people don't play nice with each other, especially in clubs.
So where do you go if you got D-Star?
It'll link into D-Star too. Yep. It'll link into, you name a digital format, it'll link in.
Right, they're all going to meld in the future.
That is, all of the proprietary groups, they can't keep doing this. It's ruining ham radio. Right? They got it. If they're going to bring all the digital together, they have to have a way to do this. Even if it's on the back end, they got to have a way. Got to have a way. Right? All right. So here's our short-term goals. So 6 to 9 months. So basically everything that we have done here is in green. So implement CTCSS on the 8.5, complete an assessment of equipment and operational status. We've done a ton of documentation on our Google Drive. We create support documents for troubleshooting systems. We had a knowledge sharing and training last month. We got everybody together here at MOBAP, and we basically did a brain dump on how to turn things on and off on the repeater system, how to get into the repeater system. I'm going to show you some things about building out the point-to-point networks, command and control for the repeaters, replace the, it's supposed to be 146.91 repeater with a spare antenna. We had an old fiberglass antenna. Now we've got a nice aluminum antenna, 8 gain. The 9.1 repeater sounds great. It has a ton of range. Asset tagged and record all equipment, greater than $50 in value. So everything down here in blue is in progress. Install the remaining Fusion repeaters, so we've installed 4 or 5. We're going to install an APRS digipeater here at MOBAP at our new location. Provide wires X on an SLSRC repeater. Making any updates. Fix broken parts, and then get the 9.7 repeater back on the air with a new antenna. So there's our command and control station.
Yes, that's the new shack.
Yeah, that's our new shack, yeah.
Wait a minute, where is this again?
It's over there. It's out there. It's in the cloud, yeah. It's DevOps. It's in the cloud. So one of the things that you got to have whenever you got a repeater system is you got to control it, right? So yesterday, you used to do this through a modem and a phone line, and you connected into the system. Today, we use the internet and VPN, right? So that's kind of opposite on how, if you're a network guru, how you do it today, right? This is how your production system lies, and then sometimes you have a modem, and that's how you get into your routers and your switches in your company. So we're totally opposite. But our production network is RF, right, and digital. So this is the hardware that we use to provide our point-to-point system, and every single repeater cabinet in our system is on the internet. It's got a path back to the internet. Okay? We use these dishes. They've got a 15-degree bandwidth. We run them at 5 megahertz bandwidth, 25 dB a gain. Here's the channel that they, or the frequency that they operate at. These things operate. They can go up to 1 watt max through part 15. I don't know what they run at. It's automatically backed down based on signal strength. So we've got these at most of the sites. These sector antennas, they're point to multi-point. So this is point to point, point to multi-point, 45-degree beam, run them at 10 megahertz bandwidth, 21 gain. Again, at the same channel, run 1 max or 1 watt max. These are all Ubiquiti devices. If you don't know anything about Ubiquiti, it's some awesome stuff. And then we run the Unify software and switches. So we've got a USG router at the 9666 Olive location. That's where our internet comes in through Charter. We've got a 200 meg by 15 connection. That USG, which is this guy, provides our VPN. We've got an 8-port switch at each location, and then we run shielded Cat6 up to the rooftop. Fresnel zone. So basically, this is something that we toy with whenever we're trying to get line of sight, good coverage. So you can bounce signals off buildings, off planes, off anything. It's something that we have to be aware about whenever we shoot a 5 gigahertz signal 6 miles, right? As this signal here is going to travel and get to this point later than this signal. So it's something that we have to be aware about. Okay. This is on top of the 8.5 building, looking southwest. So this is MOBAP. And here's 12555 Manchester. So that's 5 3/4 miles. This is 4.5 miles. And we shoot those with wireless signals.
Okay, so your main internet connection to the WAN side is at the Olive. Okay, so the other ones are point to point back to the Olive.
Most of them.
And then each one of the outlying ones has an Omni?
No.
They're all
dish.
They're all dish.
Yep.
What was the Omni antenna for? The one at
the sector antenna. The sector pushes the signal. Yeah, so we'll get into it.
Okay.
It might come apparent here. So again, this is from Olive. And this is looking into Clayton. So here is the 200 South Brentwood. Well, Skinker Boulevard is behind Clayton. And I'll show you the roadblocks that we ran into. And we just got the Skinker Boulevard on the network 2 months ago. 2 months ago, yep. So if you go to Sterling's YouTube video, he put together, this is the matrix. This is our matrix of our point-to-point links. And I'll show you a little bit about this. But these are all of the links, the potential links that you could do if you linked all of them together. Okay? Well, we had to do this because we couldn't get the 9.7 connected back to the 8.5. Because they were going through buildings and going through Clayton. So we had to figure out what was our best path to get that guy on the net. So here's the 8.5, or this is where the 9666 Olive is. So this is the building. So you can see we just built these routes and the antennas up here in the penthouse. This is basically what it looks like when it shoots. Granted, it doesn't, it doesn't go all the way to the ground, but we did that just to give us a visual aid. So these are all the points that are coming into the 8.5 today. So, like I said, we had an issue with the Skinker Boulevard, so we built these routes, and these were our possible routes. And if you look here, so the 9.7 is down here, shooting up into the 8.5 location. Well, all right, we thought, well, let's bounce it off the 9.1. Here's Brentwood Boulevard. Well, you've got this building in the way. See how it goes through the building? what is not here is there is another building that is not on Google Earth that is 10 stories taller than 200 South or 200 South Brentwood. And then if you come through Clayton, there's another building that you have to go through, and then another building. So we knew that we were kind of screwed that way too. So what did we do? We brought it. Well, we brought it down. Yeah. Unlike 2.4 gigahertz, you can kind of go through some stuff. 5 gigahertz, you can't go through anything. So we decided to bring it down, basically Highway 40, and we bounce it off of MOBAP, and then we bring it up to the 8.5 site. So this is at the MOBAP roof. This guy points to the 9.7. That's a dish. And then we've got the top dish here that points back to our WAN location. So this is basically the setup of the 5 gigahertz network. So Olive's up here, MOBAP, the 9.1, Brentwood, and Skinker. Okay. So this graph, or this drawing, represents that layout that we created to get command and control to all of the repeater sites. Okay. So these are some of the stats. The Ubiquity stuff is, it's got web pages, it gives you stats, it's awesome. It gives you logs galore. These are some of the stats that we use to look at the signal strength at all of our locations. You're probably thinking to yourself, well, this has only got half power. Well, it does and it doesn't. The real key is this transmit CCQ, quality of connection. If this guy is over 85%, you've got a strong signal. And all of our sites are, this is 88, 92, 96, 98%. And you can see some of the, it does really matter to the connection, but you can see the RxTX speed is 36 megabits. This one's 8.5. This one is 36 and 72, 19 and 72. So these are probably sometimes faster than the internet that you probably have at home.
Are you running any forward error correction?
Yeah, it's all TCP/IP. Yep. Yep.
Ping times are real short.
Yeah, so the ping times are like less than 10 milliseconds. So once you VPN in, I mean, it's like being on a LAN. It's like being on, if your corporate LAN, or the LAN inside your house. If you got a switch in your house and you're pinging, your internet gateway router, it's as quick as that. I've been really impressed with the quality and the ping times and the bandwidth that we've gotten out of this.
So is there any future opening it up to use by members?
We're getting to that. We're getting to that.
So I got a real good shot.
Yeah, we still got a lot of slides to go through. So here's the web page that you get into to look at the sector antenna. So there's the sector antenna that shoots to MOBAP and to the 9.1. And then here's the web page that we get into. It's kind of a controller-based system, and it runs on a Raspberry Pi, so it's great. Command and control. So we've got rig runners at all of the sites. They've got Anderson power poles on the back. They connect through Ethernet. They run a web page. If a repeater goes awry, we VPN into the network. We pull up this guy's web page. We turn the power off remotely. Same thing with this web power switch. We're going to get a bunch of these. It runs a web page. You can shut down a whole repeater site through AC power through a web page. So if everything has gone awry, we need to shut down power, we VPN in, shut it down remotely. And all this stuff you can get into anywhere in the world on your phone, right? I VPN through my phone, dial up the IP address, get into the web page, authenticate, hit power off, you're done.
One quick note. Those web power switches also will let you cycle power, which means it waits and it turns it back on automatically.
Yep. And it's got scripting.
Yes.
So we can do scripting to say if you don't see a pinged signal to google.com, power the router. Power off the router and power it back on. So we don't have to go up there and actually power cycle the equipment. And then old school, we do DTMF through RF, right? I don't know why that doesn't show up, but here's kind of the active stuff that we monitor now. So we monitor temp and humidity, and then we also monitor our wireless links. So that's the active stuff that we do. And in the future, the rig runners have got logic in them that says, all right, if the 8.5 repeater dips below 11 volts, send us an email. So we're going to set that up. We haven't set that up because you got to have an email relay to do that, and it's a little more advanced to secure that guy. So it's coming, but we just haven't gotten there yet. We'll also put in network monitoring, and then also the scripting language that I talked about with the digital loggers. And then you can also run what's called an automation hat on a Raspberry Pi, and it tells you like everything from how many cycles the repeater has gone through, how long it's been on the air, more voltage and amperage stuff you can get out of it. You can graph all that stuff. We've also been working on our G drive documentation. The goal is every repeater site has got the same documentation in the same location. So if I get into it, if Art gets into it, if Phil gets into it, we know exactly where all the documentation is. So at 3 o'clock in the morning, the repeater's on fire. We need to get to something that it's documented in the same location in the same way. And then also we asset tag everything. So we printed out a bunch of these asset tags, put them all in spreadsheets, can tell you exactly what's in every single repeater cabinet. All right, going to run through the slides pretty quick. Here's the Olive Boulevard site, 146.85, 443.075, 224.520.
Right in front of Stacy Park.
Yep, right beside Stacy Park. Here's the cabinet, right? So let's go through it here. Here's the 440 duplexers. Here's the internet stuff with the switch. Here's the 220 machine, some backup batteries, a PDU to distribute AC power, 2 power supplies, 2 30-amp power supplies. Here's the controller for the 8.5. Here's the 440 machine. Here's the old radios for the 8.5. Here's the new radios, the new Fusion repeater we just put in. There's the Echolink station. There's a Raspberry Pi that monitors the temperature up there, and here's some fans. That's basically everything in the cabinet. That cabinet, I think, was put in 1971.
It's a good thing they haven't changed the specs on that.
Yeah.
Yeah, the one, the 220 and the 440 is an old GE master cabinet. GE equipment.
This has got, the 8.5 has got 300 amp hour batteries. Joe thinks that we could probably power the 8.5 and the 443.075 for probably 30 to 40 hours. But keep in mind, if something happened and we needed to get power up there, we just put the generator up there, our Honda generator. So here's the antennas on the outside of the Olive Boulevard. You've got the 2-meter antenna, so that's the 146.85. You've got the dish that points to South Brentwood. On this tree, you've got the 220 antenna. We've got a spare 70-centimeter antenna. Here's that sector antenna that I had that picture of.
Is an 8.5 antenna on the north side of the building?
The 8.5 antenna is on the east side of the building. Yep.
Southeast, I guess.
Yeah, southeast. Yep. And then on the west side of the building, we commandeered some locations here that used to be owned by, I think, AT&T or some cellular provider. Oh, it was Singular. Yeah, Singular. So before my time, they decided, well, we're going to put the 8.5 repeater antenna on this side, and they did it, and they had, I think we had a bunch of interference because on the other side of this wall is a big...
That's the power panel for the building. It's on the other side of the wall. And all the noise from the computers in the building goes through that power panel. It's kind of deafening the repeater.
But it did not affect the 443.075 antenna. So this is the 443 is on the west side of the building. The 8.5 is on the east side of the building. So this antenna we're going to take down, and this is going to become Charlie's new 146.97 antenna. So this is where you find out where you live and if you're in the green, right? So this is the coverage map for the 8.5. We didn't do them for any of the other repeaters, but this is our 8 dB antenna running at, I think the 8.5 runs at about 15 watts, and this is an antenna, a 2 dB antenna at ground level. Is that what you?
You had given me all the data on that. So it's basically.
I think it's a 2 dB antenna at ground level. So this is the coverage pattern. It depends, right? So here's our work day. So you've got the guys working on the cabinet. There's Sterling putting up the sector antenna. There's Steve climbing up to put the dish antenna. It was cold that day, wasn't it, Steve? Yeah. Yeah. Here's the back of it. I know it looks like a bird's nest, but it's the best we can do. So what we did during our work day was we completed an inventory, labeled all the coax, installed the ubiquity switch, replaced the 5 gigahertz dome cover, checked all the connections, installed the Raspberry Pi. So we run dynamic DNS for the, that's how we get into the VPN, backed up the ICOM radio programming software. We didn't take any SWR power readings, but I think, Joe, you said that it runs at about 15 watts?
Yeah. It's about 15 watts, the output of the duplexer.
So future plans. Continue FM mode. Replace it with the replace the Cat 1000 with the Cat 800. We talked about that, and then potential linking during nets and disasters via the voice over IP 5 gigahertz network. We'll get into that later. 443.075. Maybe that will become our Wires X repeater. And then 224.520. We don't have any plans on doing anything special with that repeater. So that is the old
Community Federal.
There you go. So he houses the 146.91. He's the second tallest, 240 meters above sea level. Got a CTCSS of 141, 4-cavity duplexer, 30 amp power supplies, ubiquity 8-port switch up there, a rig runner for us to remotely turn off power. It's got a 5 gigahertz dish. And the nice thing about that site is it's full e-power. Because you got to buy stocks whenever there's no power, right? So there's the coverage map. Yeah. The 9.1 has got some coverage. Yeah. So we had a work day in May. We removed the old Motorola repeater, installed a new Fusion, installed the network switch, installed the rig runner, labeled all the connections, pulled Cat 6 to the out to the point-to-point dish, connected the power supplies, the coax, the duplexers, asset tagged everything. So there's there's Eric and Dan installing the antennas. Those guys are rock solid on antenna install. You guys should hire. You guys should. Yeah. Yeah. So we installed a new DB224E 4-bay antenna. Joe has got a brand new spectrum analyzer, and he brought it out and tested his duplexer. So he's got 77 dB of rejection at 1.1 dB of insertion loss at the RX, and 78 dB of rejection at 1.56 at TX. So that, whenever you put all this stuff together, the SWR was 1.7 to 1 at the 9.1. You do your calculations at 22 watts output. You might think, all right, 1.7 to 1, that's high. Well, this DB224, the specs on it are from 130 to 154. So it's a very broadband antenna. And then we also installed the 5 gigahertz connection back down to the 9.1. So here's some pictures of us doing our stuff at 9.1. Here's the old fiberglass antenna that Tony's cutting. We had to cut it in half to get it in the freight elevator. And then it went right in the dumpster.
It doesn't show you, but the guys hanging the antenna are about 20 feet over open space.
Yeah, this was, yeah, a little catwalk, yeah. Yeah, you can see it up here. I think Phil takes all our pictures, so thanks, Phil, for taking all these pictures.
Yeah, it's better than being up there.
So future plans.
Step back, you're too close.
Yeah. So we're going to continue the 9.1 and FM mode. We're going to install a new Cat 800 controller, and again, explore linking that guy with other repeaters here in the St. Louis area. There's 200 South Brentwood. There's a pool up there at the top.
And it rains heavy.
And it rains heavy, right?
At least the last time I was up there with you.
So 239 above sea level, the 9.4, 442, which is a Vertex. That guy's going to stay a Vertex. It's got a Cat 1000 controller, Astron 30 amp power supply. He's got one battery for backup. We've got a rig runner up there, got a 5 gigahertz dish. Right now we've got a Cisco 8-port switch. We're going to replace that with Ubiquity, and an engineering workday planned August of 2018. So get ready, Steve. Here's the antennas on the outside of the penthouse. So you've got the 146.94, and then here's the 442.100. This building is probably, I don't know what, Steve, 2 stories, maybe 3 stories taller. And then the building to the east is probably at least 3 or 4 stories taller. It's pretty much landlocked. So this doesn't portray what the coverage is, because I go to Illinois for my job, and I'm down here in Belleville, and I can't key it up. So, but future plans, so we're going to replace the DR1X with the 2X that we were talking about. Potentially we're going to move the 146.94 to MOBAP. We're going to take a look. It's not set in stone. It all depends on what APRS coverage we get. So we're going to put that APRS repeater in, and we're going to take a look at APRS.FI, and we're going to see how many hits and how well a coverage it has here at MOBAP. And we might move the 9.4 to here if it's got better coverage to get more people on it. Replace the cabinet with a lockable solution, so that's just an open rack. And then we're going to replace the 442 100 fiberglass antenna with a Andrews aluminum 8-gauge sometime next spring. So here's 665 Skinker Boulevard. So it's 242 meters above sea level. It's the second highest. It's got a Vertex repeater with a TE Systems 100 amp. It's got a 50 amp and a 20 amp to run. One runs the amplifier and one runs the repeater. Ubiquity 8-port switch, rig runner. It's got Wacom 4-CAN duplexers. It's got a 100 amp battery. It's got a fiberglass dual band antenna, which we're going to replace with aluminum, and then obviously a ubiquity switch.
I've got 6 cans there.
Oh, you've got 6 cans? Okay, gotcha.
Because all the other junk that's up there.
Oh, that's right, yeah. So here's the coverage map. Again, I don't think that this reflects what the 9.7 will do. I think it's got greater coverage than this, especially down here.
Yeah, Eric called that a water-cooled antenna.
Yeah, it's a water. It's got some issues. I'm eager to get a fusion up there. Well, here. Well, let's go back to the workday. So we had probably, I don't know, Charlie, how many guys? 10 guys? 10 people up there? Yep. So we're going to have another workday here soon on that repeater, but we had a broken antenna. We're going to replace it. We ran Cat 6, installed the dish, rig runner, ubiquity, 8-port switch, completed inventory, checked the SWRs about 1.7, cleaned out the cabinet, right? So here we are on the thing I wanted to point out was there is a water tower up there that supplies water. They've put this chicken wire around the top of it, and you have to crawl through the chicken wire and then walk on top of the chicken wire to get to the antenna. It's crazy.
It's a bit further fall from the 9.7.
Yeah. I think if you fell off the 9.7, it might hurt. So we're going to place that repeater with a fusion, replace the fiberglass antenna, potentially replace the coax and the connector. We're going to run the fusion in AMS mode, so that'll be a digital repeater. Maybe install that RCOM board that allows you to do cat control on the analog and allow the internal controller to do digital, and then potentially link it up with other SLSRC repeaters. Okay. And then MOBAP real quick. So this is where the site is. See that tower sticking up? That's where our site is located at. Here's where the 2 dishes are. So it's the 5th highest we've got, 40U rack, 60 amp power supply. Again, a ubiquity switch. Serves as a gateway for the 9.7, and it's on full e-power. E-power is emergency power. So here in the hospital, after 7 seconds, if the power goes off, we've got big, huge generators here, obviously to keep people alive. They kick on after 7 seconds and supplies the building with power.
I think it ever comes to about
15 seconds?
I think.
Yeah.
At least it is in my building.
I've seen it. We do a test here every month. I've seen it as quick as 3, but after 7 seconds, they all power up and everything comes back on. So here's some pictures of us. We've spent 2 work days up there. I can't remember, one in February and one a couple weeks ago, or a couple months ago, whenever we brought the 9.7 up. And then future state, we're going to put an APRS digipeater up here just to see what type of coverage it gets. Potentially move the 146.94, and because there's guest wireless, we could use this as the second internet connection into our network if the first one fails. So how are we going to link these things together? Well, there's a thing called All-Star, and it uses a Raspberry Pi with a little serial dongle here, and you can connect it to a Cat 1000 controller, and it's all done by voice over IP. So to answer your question, we're going to use the 5 gigahertz network to potentially link some of these repeaters together. We don't know which ones, and we'll get into that. And then here's the system that you can use to monitor what is linked up and what is not. And then max through together what all the repeaters, if you link them all together, that would be the coverage area that we would have in the St. Louis area. I threw this slide together. I did a Google Fusion table, and I just linked, or I just put from the membership where everyone is located. I don't really have a purpose of this slide other than you can kind of see where everyone is located. And, of course, our repeaters are in this area right here. It's a good location to have repeaters because it's kind of central.
But it's also, you're on high spots.
Yeah, like the 8.5 is the highest spot in St. Louis, right?
It's technically the spot out by Bambler State Park.
Oh, okay. Yeah.
But I'll bet you when we get 9/7 straightened out, it'll give it a run for its money in terms of coverage. Because
Yeah.
it's a 23-story apartment building. Yeah. It's up there.
Yeah. I think once we get that new antenna and we get a fusion in there, that 9.7 is going to rock. So just in summary here, here's our FM, the 8.5, the 9.1, the 9.4, the 9.7, 443, 442, and the 224. We've got two in AMS mode, so system fusion, the 9.4 and the 443. And then wires X, the future, we're going to put that on the 443. And you can get all that stuff on the repeaters and nets. Okay. All right. So I passed around the survey. Fill it out. You don't have to put your name on it. Give us your honest opinion on what you think about the repeaters, what we're going to do with them, what you like about them, what you don't like about them, general comments. Put anything you want. It's all anonymous. I don't want to. If you don't want to put your call sign, don't put your call sign. Okay. In the fall, we're going to do a more extensive survey, so be looking for that. It's going to get down to the nitty-gritty. Okay. So we've talked about a lot of this stuff. These are long-term goals, 1 to 2 years. And we talked about a lot of this stuff. But what I want to have a quick discussion on is, do you think linking some of the SLSRC repeaters, do you think that's a good idea? Think we should do that? Or should we keep them all autonomous? Does anybody have any opinions? Because we're looking at doing that. We just don't know what repeaters we're going to link together.
Kyle, just an opinion, the 8.5 and 9.1, when I have most of them scanning, are the two that are used, the 9.4, 9.7, and 5. If there's linking, then it will increase, I think, somebody that is monitoring 9.4, I think somebody's on 9.4, they may be really on 8.5 or whatever is linked to it.
Right.
I think the more you can spread out the audio, if you want to
right.
call it that, I think the better it will be.
Well, obviously, you're going to knock out some of the dead spots doing that.
Right.
Yeah.
So that's one of the. So he said to knock out some of the dead spots. So one of the things that we're looking at is if we link them all together, or link 3 of the 4 together during a net, maybe some people that have an HT might be able to get into the net easier. It all depends. For the net.
Use Bill, you're an example. You said you live almost under the 9.4, but you have a hard time getting an 8.5. And if they were linked, where are you at, Bill?
Me?
Yeah.
I'm underneath the 9.1.
9.1, what'd I say?
Yeah,
I mean,
9.1. So, I mean, with the handy-talkie and no antenna, I can hit the 9.1.
Yeah.
8.5.
How high are you out?
It depends where I am in the house.
So we're exploring linking.
No, I let mine scan
Yep.
and there's not a lot of traffic. You link them together,
Her grandson,
you're going to increase traffic.
Right.
The more traffic,
not quite that.
the more other people get on.
I know there's some high
Right.
spots out there.
Hey guys, can we? I'm having a hard time hearing.
Yeah, like he was saying, the more traffic you have, the more traffic you'll get.
Yep.
I also belong to St. Charles. We rag you after the net. And let me tell you how many emails I get where people are listening, but they don't necessarily get on. And they go, that was cool talking about the coax and this and that.
Yeah.
And they eventually get on.
Yeah.
So you need to
Yep.
do that. I really think.
Yep. It's one of the things that we're gonna really look at.
Back in the dark ages and old days when I was still involved, I think it was 8.5 was on-demand link to Sullivan and maybe on down to Rolla.
Yeah, they just get
And there was a fair amount of traffic going and coming as people came in and out, and they just would jump from one machine to another, kept the conversations going.
Yeah. we're going to make it easy to be able to link the repeaters together. So, right. So, I know that Dan, you guys, talk on your way in. Maybe it's something where we automatically, and it's all Linux based, so we can all script it. So at 5 o'clock in the morning, we link them all together, and then at 10 o'clock, we peel some repeaters off. It's very easy.
But you can also have it operate dynamically if, you're calling somebody and it's going out to several. They're calling back and it's identified which one and it's routed that way.
Yeah.
The next call may be routed this way.
Yep. Okay.
Just curiosity question to banter about. So would it be possible that, say it's not linked, but you have a script that if I kick in a DTMF tone, it would link them?
Yeah.
Say like, I know I want to get hold of, Bill, who's camped out under the 9.1.
Yep.
I'm on the 8.5 and I, throw
Yep.
in that.
Yeah, it's all going to be, publish the codes, link them all together, and then after no activity, after 10 minutes, it goes back to a default state. Yep. Okay. We'd have to take a look. Yeah, we'd have to announce something. Yeah. Yep.
You'd be routing your audio over your 5 gig.
Yeah.
Then you'd have good audio.
Yeah. So it's
Better than the internet audio.
it is. So the All-Star audio is better than digital. The codecs that they use, it's more high fidelity than digital audio. So
That's because you've got the bandwidth to spare.
yeah.
Repeat that?
It's because you got the bandwidth to spare.
The audio fidelity or video,
I just want to make sure everybody can hear.
it depends on how much bandwidth you've got, and if you're using 5 gigahertz, you've got a lot of bandwidth to play with.
Yep. Okay. So also install WiresX. Has anybody played with WiresX? No, Doug. Yeah. I mean, do you get benefit out of it? The ones that do play with it?
Actually, we do. Yeah. And we talk on it quite a bit in St. Peter's, that guy's own thing. And we're at Elmer and a couple people out there, and they're doing wires out.
Yeah.
It's good to rag chew with a guy in England, like he's in the same room.
Yeah. So I think we're going to put WiresX on that 443.075, and it will, if we put it in the default room, I mean, it probably won't get a lot of attention until we link it in with DMR, but if somebody puts it in America's room or MizWiz or Nexus Texas, there's constant banter going on those rooms.
I'd like to, for the people that are filling out the survey forms, if you haven't turned them in yet, which repeater do you use the most?
Yeah, there you go. So up at the top, put down what repeater you listen to or you use the most. Okay. And we talked about working with the Missouri Digital Group to link the DR2X repeaters together and build out a digital network. But then also, to answer your question, there are there's two different philosophies on building out mesh networks. Mesh network as in, I'm sitting at my house, I have a node up with an Omni antenna. I can see 3 other nodes that are in my neighborhood, so I link to them. It automatically, dynamically routes traffic through my node or through whatever node it is. If you get some time, go out and take a look at Arden or BBHN, that's broadband high-speed network. It is both of these use Ubiquiti hardware, which is less than $100. You can buy a whole system for about $150. We're thinking about putting together a broadband mesh network here in St. Louis. It would reside under Part 15, not 97. Part 15 allows you to do encryption. Part 97, no encryption, right? Granted, you get some less interference if you do 97, but I think we can do Part 15 a lot easier and do encryption. But basically, just think if we had a mesh network here in St. Louis and extended all the way to St. Charles, it extended down south, and we had a disaster, and the internet was knocked out, we'd still have our mesh network. If you had power at your house, we'd still have our mesh network, and we could all communicate. We could all, if the hospitals got onto this system, we could pass patient data because it's encrypted. We could do anything we wanted to with this network. But the goal is you got to have nodes in St. Louis that can see each other and communicate to each other. So maybe that's something we work towards in 2019, and we extend it up to St. Charles. We go into Illinois. We go down south, and we build this mesh network out.
That would be 5 gigahertz.
That would be both, 5 and 2.4. Yep.
2's just got, can get pretty plugged up.
Yep. 2 is pretty congested. 5, we'd probably do with 5, but we'd have to take a look. But the nice thing is, if you do part 15 and not 97, granted, if there was a disaster, we could turn, let's say there was if your house wasn't affected and had internet access, we could turn that on, and we could pipe the internet through that node, and you could get internet access. And there's checks and balances, and this is not an internet, I'm going to get free internet. That's not, it's not the point of that. It's used in a disaster, so we turn the internet on and off dynamically as we needed it. Okay? So does anybody think that's a good idea? Fred?
I have a couple of questions. First of all, is it easier to put up a repeater on one band, say, than another?
No. The problem is getting roof space.
Okay. My next question is then, if you have a general ticket, you have access to a lot more frequencies. And I noticed by the call signs in here that there's an awful lot of new names. But both 10 meters and 6 meters open up significantly at different times of the year to parts unknown. I used to work with a repeater in the Virgin Islands with an HT through a remote base in Fort Wayne, Indiana. And it can be an awful lot of fun working in distant repeaters. So I would ask the club to think about maybe putting a repeater on 6 meters or 10 meters, just because it would offer some different access to different parts of the spectrum, and allow people to get to places that they might not otherwise be able to get to.
Yeah, that thought has entered my brain. We've got that tree at the 8.5. Maybe we put a 6-meter Omni or a 10-meter Omni, if we can get a radio, and maybe tie that in somehow to one of the repeaters.
How much would a radio cost?
I'm sure that we could probably get one for a couple $100, and maybe if it was the right radio, get the PTT and discriminator out. And
If you got one of these for 10 or 6,
yeah,
cheaper.
probably. I mean, I would say we could probably do it for less than 500 easily. So.
Would this be, are you suggesting perhaps a crossband? I know at one time K9KE used to run a crossband repeater. He had it linked to, had a 2-meter repeater, I guess, linked to 6, or was it 440? I think it was a 2-meter repeater linked down to 6.
Yeah.
And he deliberately put the 6-meter antenna down pretty low so that it really only worked when the band was open. But the idea was people could go enjoy working some 6-meter DX through the repeater.
So,
and back in the day, it wasn't uncommon for 2-meter repeaters to have 10-meter links.
yeah.
It was
So,
also linked to 10 meters.
Was it?
Yeah.
Because when I first got my 2-meter rig in that, I'd go to that repeater and I'd talk all over.
So I think The goal for 2018, you can probably tell, was to get the repeater system stable, get command and control. Once we do that, we get all these repeaters up and running, and they're running at full power, they're stable. In 2019, like the mesh network, we can start experimenting, and we can start doing some really cool stuff with it.
And you can be dynamically cross-banding. A guy at one end of the mesh network can be 2 meters and 70 centimeters and 6 meters.
The 5 gigahertz network that we put in allows us to do so many things. It's just the start of the things that we can do.
We used to have a 6-meter setup down in Furman, Deloge, and one of the other hospitals over there. Nobody ever used it.
Yeah. So I don't want to put a lot of time and effort into something that people are not going to use. Granted, it's a great experiment to see if you can get it on the air, but if people aren't going to use it, it's something that we need to take a look at.
But if somebody can get into the mesh and wants to, experiment with some odd part you're going with.
Yeah. So, all right. The answers to the pop quiz. How many repeaters does SLSRC maintain? 7. How many repeater sites do we have? 5. How many SLSRC repeaters operate in the 2-meter band? 4. How many in the 70 centimeter? We got 2. Yaesu is the manufacturer of System Fusion. We've got 2 System Fusion repeaters on the air, and Community Federal is the old building. All right, questions?
Must be a little farmhouse there before Community Federal.
Really?
Yeah. Back in the days when the Manchester Drive-In was where West County.
All right, I said I was going to be out at 9. I went 5 minutes over. I'm sorry.